Welcome to this tutorial in Transform 2022. This is the latest edition of our sort of festival of, what should we call it, digital subsurface stuff. And what that really means, it's sort of a content creation festival, basically. We've got a bunch of tutorials happening this week. They're all live. You can tune in on YouTube Live, like you may be doing right now. Or they'll be on YouTube for the rest of eternity, so you can catch up with them there too. There's also some meetups happening. We've got the Software Underground annual general meeting happening this week, so it's a big week. Software Underground is this community of folks who are into this sort of thing, rocks and computers, basically. So welcome if this is your first experience with Software Underground. You need to know that I've turned off the chat in YouTube because there's an awesome Slack that you need to hear about. softwareunderground.org/Slack, or I think it's actually on softwareunderground.org homepage as well. You can go in there if you're not in the Slack already and create an account, and you're looking for the channels inside our Slack, starting with T22. Okay, so T22 general, and then there's a special channel for this tutorial called T22 for Tuesday packaging or something like that. What else? Thank you very much to curvenote.com for sponsoring this event. The whole of Transform. They're doing amazing things with scientific communication, basically, in the written word, along with mathematics, plots and images and code. So fully executable documents is their sort of goal. Go and check them out if you're not aware of them already, and thank you again to them. Let's see. Yeah. Oh, I guess if you want to find out about the other things going on in Transform, softwareunderground.org/transform will take you to things where you can see the schedule. You can also just like follow our Twitter, swung.org, and keep in touch with what's going on. But the Slack is the place. The Slack is the best place. So, welcome. We're going to spend the next, more than an hour, less than 2 hours, talking about packaging, Python packaging. A way to get your code into other developers' hands, really. So we're not talking about creating an application for an end user to use with menus and things like that. This is a way to get your code to other people who are writing Python code who might want to use your functions and your classes or whatever it is you've built in their projects. And packaging your project is going to make it way easier for people to use than, say, emailing them a Python file or a zip file, or pointing them at some scrappy GitHub that you keep for your stuff. Those kinds of things, which you're still going to do. Packaging is not going to solve all of those problems, but it's going to give you a really nice channel for putting your stuff in the right place where pip can find it, basically. So you're going to be able to do pip install your package, and so is anybody else. And that's how, I think it's going to, if you're not doing it already, it's going to really transform how you write code, how you maintain your code, how you share it, and potentially even how you think about yourself as a developer, right? There's a kind of, I don't know, with great power comes great responsibility kind of thing going on. Okay, before I say anything else, I should just, I had to change my t-shirt today because I've discovered that pretty much every single Software Underground t-shirt has green on it. Obviously I don't have a giant screen behind me. That's a green thing. And even this one, this is from the geothermal hackathon that kind of we had to rapidly move online because COVID. So I never really got to hand these t-shirts out, unfortunately. But if I move that way, I guess you can see straight through the middle of me, which is kind of cool. But now that I know this, I'll probably make some t-shirts that don't have green, but maybe we'll make some t-shirts that definitely do have strategically placed green and can do some interesting things online when you're streaming your nonsense tutorials. Okay, so let's talk about packaging. I have got a few slides. We are going to do lots of coding, but I found as I was going, it's like, oh wow, I've generated a lot of notes that I thought, well, I might as well share these with you so that you don't have to write down a lot of notes. And I've put them in here. So the URL to this deck is right there. It's a Google Slides. So excuse me, if you can't use that, if you can't get to that for some reason, well, I'll tell you what, I'll put the PDF, why don't I put the PDF right now in Slack? I didn't think of doing that before. I might have to do it again at the end because I may add to this as we go, just, you know. Boom, so there it is in the Slack wallop. Now Firefox has done that. Let's go back to this. Let's close that. Okay, so hopefully everyone's got some version of the slidey things going on now. There's me, I'm Matt, I'm Agile, I'm a co-founder of the Software Underground as well, and you'll find me easily in Slack if you need to get in touch, or you can email me if you don't want me to get in touch, because I'm not very good at email these days. Okay, I'll let you read that. I should have looked up where this borrowed and butchered quote comes from. This is actually originally a quote about regular expressions, where you've got a text processing problem. But, you know, Python packaging has definitely historically and arguably even today been a bit of a nightmare, basically. I am not a good enough programmer to know why exactly or what about it is so difficult. But it just seems to be a super tricky problem. And so don't feel bad when you start looking around and feeling really unable to figure it out, even with, or perhaps because of Stack Overflow, even with YouTube, even with videos like hopefully this one, and even with your colleagues, you still can't get to the bottom of it because basically it's just really hard. The good news is that it's getting better and better all the time. And a few years ago, like this is even from 2018, but I mean, definitely you look back to 2012 to 16. I mean, just maintaining your Python environment was super, super difficult and unpleasant. It was super easy to break and you'd end up not being able to run stuff you could run yesterday. And if you were on a Mac, you've got Homebrew in there, like this funny comic intimates. And, you know, there's just all these sort of pieces floating around. And it's really out of this miasma that Conda emerged from the company that's now called Anaconda. And Conda did solve a lot of problems and make a lot of things much easier. Like I was using environments really haphazardly before Conda. Some things like anything that involves GDAL, for example, was really tricky to install before Conda. And so, yeah, it changed a lot of things for especially scientific Python developers. I feel like Python and the core tools in Python are coming back up to the point where maybe we won't need Conda for much longer. And actually, I don't build my stuff now for Conda because I don't want yet another thing to maintain, and Pip seems to do an awesome job. So it's not like this anymore. That's what I wanted to say there. By the way, I should say, you know, I am not a packaging expert. I have built quite a few packages in various different ways over the years, and I'm not a great maintainer either. So part of me is like, well, maybe you shouldn't be learning from me. But I feel like I have tried to find the path of least resistance and least maintenance overhead. So I could be totally wrong about that. And so one of the things I wanted to say was, you know, if you're sitting there, you know, I'm seeing lots of awesome devs in the Slack chat, for example. I mean, I really hope Leo Uyeda's not listening to me, because there are tons of really fantastic package maintainers out there in our community. I hope that they will chime in and correct me when I'm talking garbage, suggest alternatives, and point you and me at other tools that are out there that are going to help you out. But know that they're in the community. So if you do run into trouble, I'm always more than happy to try and help where I can. But the folks who are maintaining these other amazing packages out there, PyGimli and Simpeg and Fatiendo and DeVito and all the rest of it, will also swing in and help you. Like, this is a great community for that. Okay. So next thing, I guess, was, there are some alternatives to packaging that I just wanted to sort of highlight. You probably already share IPython notebooks. Do we still call them that? I guess Jupyter notebooks we call them now. I'm always a pretty long way behind the curve, FYI. Emailing around .py files, sharing code snippets, of course, in places like Software Underground. Using Gist. I really like Gist. I think it's a nice add-on to GitHub for when you've basically just got one or two files to share. And it has kind of a super lightweight version control, so you can go back and see old stuff or old versions. And you get a URL, of course, for your code, so it's really easy to share that around. So that's a great option for little snippets. The thing is, you can't really send along dependencies with that. The person has to read the imports at the top, go and install the things that they need. And there's really no guarantee that they're going to be able to run your code. You may or may not have documented what versions of Python you're expecting to run on, things like that. And of course, there's also no way for them to install that code. Or that's not true. There are always ways. There's no obvious and easy way for them to install that code so that they can, download your .py file from Gist or whatever, and then go over to another project and go, from mat source and package import foo. That's not going to work. Making functionality available, without code. So in other words, helping other developers by giving them a tool to get stuff done with Python or any other language could be achieved through something like a web API. So you could stand up a web application that serves requests for such and such. One of the things that totally was a real epiphany for me back in like 2011, Evan and I were playing with making Android applications, sort of. And we needed to make charts, and Google has this amazing, or had this amazing charts API. You could literally just send a URL that contained your data and your configuration for the chart, the parameters, and it would send back a PNG with your chart. That's really cool and means you don't have to expose any code to anybody. It does mean that the person needs to be online to use it, though, of course. And then I've also got in here freezing your code, which basically means building an exe or a dot package or something like that to install on a Mac. And I'm including in there, although it's not quite the same thing, building something like a deb file or package for basically a Linux distro. That's what, say, Dropbox does. Dropbox is written in Python, and you install it, it just looks like a regular application. But the thing about that is you can make certain guarantees about the environment because the application brings the environment with it. But it's not, I think you can completely hide the code from people when you do that. There's no reason in general why those sorts of, those users, desktop application users, are going to want to see your code anyway. Anyway, if you get to the bottom of that list and you're like, yeah, I still want to build a package, cool. Here's what I'm sort of assuming for today. Sorry. I'm still getting over COVID. Seems like it's moved right down to my chest. Where that hole is, that's probably related. I don't know. I wish that was bigger now. I really wish I could really see stuff through there. You can even see through the chair, which is... okay. So I'm assuming you've got something written in Python already that you want to distribute. And like I've been saying in the chat, if you haven't, see if you can dig one out now while I'm talking. I also provided in the chat, in that thread, you'll have to scroll up a minute. Let me just pin it so it stands out in yellow. I said, time to think about, you've still got time, well, you haven't anymore, got time to think about a tiny project, ideally like a single notebook or Python file. And then I've given you a completely rubbish function. If you really can't think of anything, I'm sure you can. You know, just implement, I don't know, Gardner's equation or something. I've given you a little hello world function, which you could totally just put in a Python file and use. But I'm not going to talk about including stuff like Cython, like C code that's in your Python project and that sort of thing. I guess my assumption there is if you're doing that, you've probably got the chops already to figure out Python packaging. If you haven't, then good on you, and please stick with it because I want to see your package for sure. But I know nothing about making that sort of stuff happen. I'm assuming you want it to be installable by pip, and for the purposes of today, we're not thinking about Conda. I'm assuming that you want to follow the kind of best recommended, currently recommended by the Python Foundation and sort of thing, and the Python Packaging Authority, their current best advice. Because, and I'm saying that because the current best advice, as far as I can tell, as a kind of a noob, is not the same as the prevalent advice on the internet. You know, if you want to follow the prevalent advice, go for it. There's tons of it out there. You can definitely make something work. I'm assuming that you prefer sort of getting into the nitty gritty a little bit. Like I'm not, you know, don't need to go all the way with this idea, but I think it's a good way to figure something out and understand what the tricky things are, what various words mean. It's just a good way to get started, kind of going in at the ground floor. Even if you then abandon the ground floor and go, you know what, I'm just going to use poetry, which I'll tell you about later, and not worry too much about all of this other setup tools stuff. And I guess the other aspect to that first principles is this is the stuff that comes with Python on the whole. For the most part, we're not going to need to pip install very much to get this done. You're going to need patience. Like it's just how it is. You're going to need to Google things. But I've got a good trick for Google that has really helped me out over the last few weeks as I've been looking into packaging again. Let's move that on. Okay. So there's various pieces of bad news, unfortunately. Basically, everything's changing all the time, constantly. So there was a big change on the 25th of March, a month ago, exactly a month ago. That is great news that I'll explain shortly. But I'm not using that feature of Python today. Like we're gonna slightly use it. I know this doesn't make sense. It will make sense. But we are going to use a bit of the good stuff that came out on the 25th of March. But when I tried exclusively doing it that way, you know, it comes with the notice, which I'll show you, comes with a thing saying, you know, this is brand new functionality. We're testing it. It may break. We may change it. It didn't quite do what I wanted it to do. So there are these two PEPs. PEPs are how the Python community figures out what Python should be and what it's going to include in the future. So it's, you know, you've probably heard of PEP 8, which is the sort of de facto standard for laying out Python code and how it should look in your editor. So you probably haven't heard of PEP 5.17 and 5.18, and maybe you're surprised to hear that the PEPs go up this high, but they keep going. And there are new ones all the time, and they're quite interesting to read through because they do capture some of the, well, basically all of the salient discussion that happened around any given item. But these two PEPs describe the goal for packaging in Python. And my understanding of poetry, which is a package you can use for packaging, is that it tries to sort of be the future of Python packaging. So in a way, poetry is like a sort of canary in the mine, trying to figure out, you know, if we redesigned everything from scratch and it all looked beautiful, how would it look? And I think that's the goal of poetry. I have not used poetry, so I don't really know. But people, you know, just last week, Graham Gansel was telling me to use it, basically. Okay, so most people, from what I can tell, from the videos that I see and the repos that I look at, most people are still using setup.py. You've probably heard of setup.py or seen it around, and for a long time, it was the way to get stuff done with packaging. But the current advice is, and the goal is to have no setup.py whatsoever, or at least it will be created automatically for you in the background, but you don't really need to know that. And the reason for that, from what I can gather, is basically you just don't want executable code being used to build things, because nefarious things could potentially happen. I suppose that's one consideration. You know, you're executing a Python file in order to install something. But the other thing is that it means that all sorts of dynamic things can happen. So things can change dynamically at install time, and that makes packaging a headache, and it means different things might happen for different users. And basically that's just the scenario that they're trying to avoid. So the goal instead is to have a single metadata file, like you've probably seen init files or YAML files or config files, this sort of thing, and have a completely static, deterministic way to build a project that only contains a bunch of metadata, and there's only one such file. Okay, so we're not there yet. The goal is for that file to be pyproject.toml. What the heck's toml? It's another markup language. I don't know where it came from. Somebody did the old XKCD thing of looking at all the standards, and there wasn't the right standard, so they made another standard. You know, they looked at JSON, which some people might think would be an obvious choice given the way the web is these days. But they decided, for example, it's not human editable enough. So they didn't want that. They looked at YAML, but other reasons rejected that. Unfortunately, we're not at the point where you can just put everything in pyproject.toml. And personally, I find the format in there a little bit weird. And also, the way I've got my editor set up, it doesn't highlight it properly. I'm certain that's something I could easily fix, but it's these ridiculous little things that slow you down, right? So currently, you almost certainly also need this other thing called setup.config, which is a bit like setup.py used to be, except it's not a Python file. It's one of these configuration files. So you can't run it. It's not executable. Okay. I apologize for all this. I wanted to give you some background. I guess you can't fast forward it yet. If you're watching this on YouTube later, you could just skip all this until we get to actually typing some code. But for now, you're stuck with me. If it turns out you can fast forward it already, that's cool. Please tell me what I'm going to say later on. Okay, so one of my goals for today was to figure out, because I hadn't really done this for quite a while, like what's the absolute minimum you need to do to put something on PyPI. PyPI is the Python package index, or the cheese shop. It used to be called the cheese shop. I haven't heard anyone call it that for a while. But anyway, I'm resurrecting cheese shop, which is where pip by default looks for stuff. When you go pip install foo, it goes to the Python package index, pypi.org, to look there for that package. So so what we're going to do first is do the absolute minimum, and then we'll publish something, and then we'll go back and say, okay, now that we know what the minimum is, how do we make this actually a viable, community friendly, maintainer friendly, contribution friendly, open source Python package. Now, how far are we going to get into that second half? I'm not totally sure. I mean, I guess not very far, because it goes on for infinity. So basically, we might get a little way into it. But we've got some things to talk about potentially, like testing, like documentation, and all of those things are giant subjects that we can't do justice to. But I can point you at things. And hopefully, once we've done this, you'll, have a clearer picture of like, oh, okay, that's what I need to pay attention to. Because, if we go to, let's go to Welly on GitHub. This is a package that I maintain. What you may have done in the past is look at a repo that you exists and is installable, etc., and just go, flippin' heck. like there's a lot of files there, and only one of these folders actually appears to contain code. So what on earth is going on? Like, what's the other sort of 80% of this repo about? And sorry, I should blow up GitHub a bit. So that's what we're going to start unpicking, and we'll start with the things that are necessary. So here's what we're going to do. I think we'll just do this rather than me kind of going through this. So let's just start. We're going to, well, I'll tell you what, I'll start. I should have put a 0 on here because it's Python. Let's do that. Because I don't think I've, yeah. Oh, you can't, well, surely I can start with 0. Format options. Ah, should have looked at this, shouldn't I? Okay, anyway, 0, 1, that's not what I want. This is ridiculous. Why am I spending time on this? I just like the idea. Okay, have some Python code. Okay, or a project or whatever it is. If anyone figures out how to bullets and numbering, here we go. Restart. Yeah. Okay. There we go. All right. So what I'll show you what I'm going to start with today. I've got a notebook. Okay, so it's dynamic time warping. I've called it dynamic whatever warping because of course you don't just have to have signals in time. As we all know, you can have something like a well log or seismic in depth or whatever. And I'm sure you can think of other bases like a spatial basis where you've got like a signal in 1D or 2D space. So I read a bunch of blog posts. This was a couple of years ago, I think at the beginning of COVID, and this awesome Wikipedia page which has a bunch of pseudocode on it. And here's my function to build a dynamic time warp cost matrix out of 2 signals. So rather than, I'm not going to explain what it does, but you know, this classic notebook. Oh, it looks like I've already run this. I suppose probably checking everything worked. There we go. Is that big enough? And then I'm going to give it these 2 signals, right? So I've got a bunch of 1s with 2 3s in it. So it's like 1 1 1 3, 1 1 1 3, and then I've got a very similar looking signal, but it's kind of compressed, if you like, contracted, because it's just got 2 1s in between the 3s. And the idea with dynamic time warping is we would like those 3s to be correlated, because if you imagine there's sort of 2 signals, they've both got 2 spikes in them, and the idea is that the spikes correlate with each other. So I want this algorithm to detect that. Now, the way it works is you start off by computing a cost matrix, which looks like this thing. We can plot that because it's a 2D matrix, and that's what it looks like in 2D. And what you're seeing here is the 2 signals, if you like, on the axes. So the longer signal with the extra 1s in it is on the vertical axis, short signal on the other one. And where there are 1s, we're getting this darker color means low cost. We're getting a big blob of low cost, and the idea there is that the algorithm doesn't know how to correlate those things. So it has a sort of default strategy for dealing there. But where those 1s, or sorry, where those 3s are, it's only got one option. There's 1 square there with low cost. So when we try to navigate away a single path, which is what the correlation essentially amounts to, is a path through this matrix, it's going to be constrained there to be at that point, because it knows or it thinks that those points correlate. Okay, so now we have to build the path, and the way that works is we use a sort of backtracking algorithm. So it starts at the end, and then it just looks and tries to find the lowest cost option in front of it, and it takes a step, and then it looks for the next lowest cost, and so on. So that's this algorithm, which I built from another bit of pseudocode. I know that it's super loopy and stuff, but I tried a lot of NumPy things in here, and the loops were fast, but I haven't tested it on giant arrays or anything like that. Anyway, here's the path. And what you can see, if I just show you the signals again, whoops, S1 is basically we've got the index numbers of the long signal here and the index numbers of the short signal. And what the path is doing is it's trying to take steps, and it's saying this correlates with that, that point correlates with this point. So what we're interested in is like 0, 1, 2. There's the 2 in the short signal, and it's saying that corresponds to index 3, this one, in the long signal. And you see it's constrained there, whereas in between it doesn't really know. So lots of points correlate with these other points. It sort of gets a bit confused, basically. Same thing for the other constrained point, sorry, which is this one here. 5, right? 0, 1, 2, 3, 4, 5, yeah. Okay, and then we can combine those two things because basically you always want to do both of them. By the way, I wrote this because I found a lot of, there's lots of dynamic time warping packages out there, but many of them only give you the path. And I wanted the cost matrix, so that was what got me into this in the first place. There's others out there that also give you the cost matrix, don't get me wrong. Okay, so let's just put them both in a function which calls both things and passes back both things in the return, and now we get both the cost. Don't really need that, do I? And what I can do now is say, okay, well, give me the path as a bunch of coordinates, and then I can plot it onto the cost. So you could also make a cute plot where you actually show the correlations, but that's quite a lot of code, or at least the way I did it. So I haven't included that. So that's going to be my package basically. But let's do this. Excuse me. First, I'll tell you what. I'm just going to leave it at that for now. We'll go to step 2 or 1 or whichever step I'm on now. We are going to make a repo. So I asked you or suggested that you make a GitHub account the other day. Maybe use GitLab or some other repo management tool. Doesn't really matter. But the idea is I tend to make the repo first and then put the code in it. I find that easier. And you'll probably see why in a second. So I'm going to click on this new button here. And I'm not going to use a template. We'll talk about templates later if I get a chance. But basically the idea is you may have a kind of empty repo that you use, and GitHub can use that to start off new repos, which is kind of cool. So I do have one actually that I use sometimes to start new repos because I know it's got all this stuff that we're going to do today in it already. Okay, so the owner is going to be me. I'm going to call this, we need a name. So I'm going to go now to PyPI. So go over to pypi.org because you want to start off, you don't really want to change the name of your project. You definitely can, like it's not a big deal. You can search and replace, or there are even tools, excuse me, to help you rename things. But you might as well start off with the name you're going to keep. And just like if you're thinking about, a company, you need to check if the URL, if the domain exists. When you're starting a Python project, you want to check that the name is open for you on PyPI. So, if I search for, let's search for pandas. You'll notice there's a lot of things with pandas in the name. And some people nefariously put out packages with very similar names or typos in them to try and get people to download evil code. But PyPI has done a reasonable job of recognizing that the one you probably want is there. So that's the one you recognize, and then there's all these other things. DTW, there'll be, these exist, and even things like PyDTW, not there either. But I was calling mine DXW, and I think that was available. Okay, so I can use DXW, and that's what I'm going to go with. Now, we are going to put stuff on PyPI. Don't worry about doing something banal on PyPI. It's totally fine. There are no rules. You can always delete it as well. So if you put a hello world package on there, it's fine. And if you're having trouble finding a name, or you're going to delete it, just sort of put your name at the end of it or something like that. just to sort of, you know, so that you, if you forget, you're not taking up a cool name or whatever. Up to you, but just settle on something. Doesn't really matter what it is, if you don't think you're going to keep it. So let's call this DXW. Short and memorable. I guess GitHub suggests names. I don't really get their suggestions. I would never use any of them. But anyway, so this is going to be simple, dynamic, time warping. I think it's always good to fill these things out because it sort of shows you where they show up. You're like, oh, that's what that is. It's going to be public. By all means, keep it private if you want. There's no correlation between the privacy of your GitHub project and your PyPI thing. And then I want you to do this, add a README, and you do want to add a git ignore. You know, you're almost certainly going to want it eventually anyway, and the git ignore that you get comes with things that should be in there, kind of thing. So just make sure you use the Python one. And then I would suggest adding a license. I mean, if you're putting code on the internet, you should probably choose a license for it. Now, this code that I've used probably contains DNA from those blog posts, and the Wikipedia doesn't really, like, goodness knows what they think of code snippets. In fact, it's not code, it's pseudocode. But anyway, I'm going to use the LGPL for it, because that's how the Wikipedia stuff is licensed. The other stuff, you know, bit of a gray area potentially, but I don't think my code's that similar. Anyway, I guess if you're having trouble choosing a license, I do have, I have a blog post here. I'll give you this, which basically just tries to sort of spell out what some of the features of the most common open licenses are. My view on licenses. There's also this awesome choosealicense.com, which basically just says use MIT or use the GPL. But it does have lots of information about all the other licenses you can imagine. I mean, basically it's saying if you want a permissive license, in other words, one that has the minimum requirements of the licensees, they really just need to say where they got the code and carry that license with the code they use. Which is probably what you want for most open source stuff most of the time, but it's totally up to you. Or if you want the share alike component, where if someone changes and distributes the changed code, they have to share the changes back to the community and to you as the developer. A lot of companies use this for their code because they want to guarantee that they get improvements that are out there. There is another thing kind of halfway in between these two things called the LGPL, which is what I just used, which has these features, but they only apply to that code base itself. The thing with the GPL is that in principle, it spreads to the other code that's being used in that project. So if you use a GPL library, it basically turns your whole project into a GPL project, which may or may not be what you want. Anyway, there's long historical debates about that stuff in Software Underground, so just go and Google GPL if you want some entertainment. I normally use the Apache 2.0 license because it contains some specific things that try to prevent essentially stamp out poor behavior by patent trolls. In a few different ways, and that's why I like it. But it is a much longer license than something like MIT or the short BSD licenses. Anyway, read the post if you want to know more about that stuff. And then you can click on Create Repository, and here we go. Here's what we get. We actually get for free. Well, not really the git ignore, that's just for Git, but we get 2 of the things that you need in your project anyway, so that saved us a little bit of hassle. And what you can do now is go to this code thing and go copy the code you need to clone it. So if you use SSH, you use this one, or if you're using the HTTP method, then use that. Or you can download the zip file, I guess, if you're not sure what to do or don't know how to clone a repo yet. Okay, so now I can come over here. So I am in a, I'm just where I keep my projects. I'm not in an environment or anything yet. We'll create an environment next. So, well, first let's clone, git clone that thing that you just got. And there it is. And I suggest also making an environment for your project at this point. So let's do that. I generally use the same name for the project or for the environment as I do for the project, so that I don't go crazy trying to remember what goes with what. Let's do Python 3.10. Can be up to date. And I know that my thing uses NumPy, so I'm going to add that right away. And anything else that it turns out that we need, we'll just add it later. Excuse me. The repo name does not need to match the PyPI name, but I think it'll help you keep things straight in your head if it does. One of the underlying sort of I guess reasons why they're constantly changing the Python packaging universe is to try and they're trying to become completely agnostic to the tools. So you can build a project without even using Python. You can build projects for different targets. You can integrate Conda more easily. Like, the goal is to be totally interoperable. And I guess the idea with the old way of doing things with distutils and setup tools was that it was too baked into make everything in Python, put it on PyPI. So that was one of the things is they're trying to sort of dissociate these. So, okay, my thing finished making, so we're going to conda activate. I'm using conda, but you could use VM or whatever you like to make your environment. I'm going to go so far as to say you definitely want environments for developing a package, unless you really know your way around your system. I know there are lots of fantastic developers that don't use environments. You're just going to make things much easier for you, basically. Conda activate DXW. Okay, cool. So now we're in our project. We've got the files that we added in GitHub, and now we need some code, and we need to sort of build the basic framework around our stuff so that we can package it. Okay, so let's go back and I'm going to go back now to the notebook, and let's see how much of this we can see at the same time. Just about okay. I've still got a space for me to vibe around. Anyway, so here we go. Back to the notebook. I'm going to go File. I don't usually do this. I usually would just actually copy and paste stuff, but this is probably a mistake, actually. I love departing from my usual workflow in the middle of a live tutorial. So export as a script or a .py file or whatever it says in your client. There's the file. It's in my downloads. Now I need to put that in my project. So I'm just going to copy it, well, move it. Now I'm in Linux here, so you may want to use the File Explorer. If you're not familiar with the command line, you're on Windows, or if you're on a Mac, you can do the same as me. Downloads. What was it called? Simple. Oh, right. It's got the name of the notebook. To here. Okay, now I've got my file. Now I'm actually going to move it. And I've been really debating now what to tell you about this next bit, because you've just got to know that there are two ways of doing this. There are two kinds of tree we can have. Let's maybe, I think there's something right in here I can use to show you the two kinds. Okay, so there's two kinds of layouts for a project. There's what's known as a flat layout, apparently also known as ad hoc. This is what as a brief survey of packages yesterday left me feeling like this is what most people do. Okay, so most people have their project root directory, which in my case is this DXW. Okay, and then they have these config files and whatnot that I was just talking about earlier. We'll make in a minute. And then they have a folder called whatever their package is called, which for most people is also going to be the name of the root folder. And then they have their files, their actual Python code in there. And this is actually how I do all of my projects as well. All right. Now, some people get, as you know, on the internet, people have very strong opinions about things. And one of the things that Python packaging people have really strong opinions about is this layout. And a lot of people don't like it. They're mostly Uber programmers, as far as I can tell. So they, in other words, that's another way of saying that they don't like it for reasons which might be quite hard to understand, but which are probably totally valid. So I saw, I trust them. I trust the smart people, the geeks, but I don't fully understand the issues. There's a little bit of description here about it. If I scroll up, let's look at the alternative, because this is what they are advocating, is having a package called, a folder directory called src in your distribution, in your project, and that thing contains the sub packages, modules, Python files, etc., etc. Okay. Now you might be sitting there going, "Who cares? What difference does it make?" And luckily, the answer is actually now, as far as I can tell, it doesn't make too much difference. If you'd asked me a little while ago, because I have tried using Source in the past, I ran into trouble with getting my tests to work, with getting paths sorted out, and just getting things to work properly. Probably because I was confused about things because I was used to the other way. Maybe that was it. I don't know. But I can also tell you that as of very recently, setup tools, which is the scheme, if you like, that we're using to build our project, and it is a Python package, a Python project, has made it much easier to choose one and it'll work. Okay, so in the spirit of doing things for the first time during a live tutorial, I'm going to use the source layout because, like I say, I believe the people who say this is how you should do it. And we'll all be on a journey of discovery. But I will tell you how to do both. Okay, so I'll show you what you'll need to change, because so far I've only discovered one thing. Now, in about 45 minutes, I might backpedal rapidly and go the other way because things are completely broken. But until that time, I'm going to try the source layout. And yeah, there's only one line of code that we change. Okay, in theory. So let's go with it. So I'm going to make a source directory, and I'm going to make another directory in there that has the name of my package. Now, oh, by the way, if you already know that your package is going to have lots of sub packages, so what I mean is, like, if you think about NumPy, that's got numpy.this and numpy.that, but it's also got numpy.fft and numpy.linalg. And if you think about something like scikit-learn, that's all sub packages, right? Or super modules. I don't know exactly what to call them. You've got like sklearn.linear, and that contains all the linear stuff. You've got sklearn.svm, and that contains all the support vector stuff. If you already know that you're probably going to want that, you definitely want to choose the source route, from what I gather. Now, I did go down that road in Bruges with the multi sub packages and so on, and I do still not totally understand that repo, which is pretty worrying. Anyway, so I'm going to create mkdir source and mkdir source / dxw, and then I'm going to move simple dxw into source dxw, And I'm actually going to rename it at the same time because like, I know it seems like everything's got the same name. It's like, hang on, the PyPI thing, it's got the same name. The GitHub repo, the folder this is in, the folder in source, and now I'm going to use the same name for the Python file. You don't have to do this, but if you've only got one module or one Python file, you know, you're probably just going to call it that. Okay, now let's, well, I'll tell you what, since we can do this, let's do tree. So you can see there what the where is that? There. The structure of my folder. And you can see that it looks more or less like that one. Except it hasn't got as many files, or it's got different files. Now, the alternative, you can see there, maybe I won't do it right now, but I'm sure you can imagine for yourself, just move that DXW folder up one or down one, or however you think about things. I think of that as going down towards the root. Yeah, I'm not having a source folder. That would be the other way. Okay, now cd source DXW. I guess the one thing is you end up with these longer paths. Like if you don't like that, stick to the other one, I would say. Now I want to edit this file because I know that it's got a bunch of garbage in it from the notebook. Well, I say garbage, you know. Whoops. How many times did I hit that? I've turned my Copilot off. I don't know if I can live without it, but I'll try. Okay, so I'm going to get rid of that. And I don't... Well, you know what? I might keep some of this because I don't want to lose attributions and things. Although that's going to need some reformatting. We can worry about that later. You know, the general advice, I think, still is that it's not a terrible idea to have encoding information at the top of your Python files. If your file is not executable, you don't need that hash bang Python executable line that it put in at the beginning. And you don't generally want that in a package anyway, so I would just take that out. There are other ways of making your stuff executable with the package. But you do want authorship information. And you do want a way for people to get in touch with you and so on. So I would put those in. And you want the license. Now, why put that into every file? Well, again, the prevailing advice just seems to be, and actually, I know this from my own experience. The code is going to get, it's going to get split up. People are going to use individual files. You're going to use individual files. It's not necessarily going to be a contiguous piece of code. It just makes sense to put your copyright notice where it's very easy for people to comply with your license. Okay, now I guess actually I only want the functions from this, so I'm going to delete everything else. I don't want all this other stuff, and I don't want the plotting in there. I don't want this. I want that function. I don't need any of this stuff that runs kind of in the interpreter. Don't need this. Just that function. Got 2 returns in between your functions in a module according to PEP8, and I can get rid of all of that. Okay. Now we are going to revisit this file, but for now I'm going to say that that is good. Don't like the way it does that. I'm going to save that. Now, that's our file. We are ready. Assuming, we were running that and it basically worked. We are ready to add some. So for now, that was my test, was running it in the notebook. But we're ready to add these other files that it's talking about over here. Now, I didn't really talk much about this yet, but you will find websites all over the place, right, for advice. But here's what has been working for me. Let's start at the beginning. There's a thing called the PyPI, the Python Packaging Authority. Rather grandiose name. This points to some useful things, like the Python Packaging User Guide is actually pretty good, but I find that it's very adaptable to pretty much any situation, and most of those situations don't apply to most people most of the time. Okay, so it's great, it's super comprehensive, and I think if you came to this, especially like this bit here, this tutorial on packaging and distributing, well, I don't know, actually this document's pretty good, to be honest. And it's more or less what we're going to do. But, so that's one great, canonical, solid place to get advice that's up to date. I really like how they have these, you know, here's what you do on different platforms and here's what you do for different approaches and so on. But best of all, I find the setup tools. You can see it's a PyPI project. The setup tools documentation is awesome, I think. And it's super up to date. And it's fully aware of all of these new PEP 517, 518 business. So where you want to go in here is user guide, and then just go to the setup tools quick start. Okay, so I can give you the URL to that. Thanks, Martin, for helping out with the questions there. Yeah, absolutely. Well, I'm going to put the tests outside the source directory, but certainly people do other things too. Okay, so let's have a look over here. Let's do what it's suggesting. We're going to go pip install -- upgrade setup tools so that we know we're using the latest version. Now, if you just created this, you probably are. Looks like I've upgraded by 1 point, sort of thing, with that. And I can tell you that, well, no, we'll wait till we get to it. So here we go with the pyproject.toml. We are going to use that pattern, I think, unadulterated. Let me just double check. Sorry. Yeah, we can actually start with exactly this. So let's come back over here and go codes pyproject.toml and just paste that in there. And this is going to be called, well, it's already got a name. And then I'm going to make a new one. I'll just do that from here. Let's go back to the advice. Now it wants us to make setup.config. Okay, now let me just make sure I do this the way that's compatible with what I've chosen to do. I'll tell you what, let's start with what they're giving us. Now what they're saying here is that basically there are 3 ways of doing this next bit, which is we're passing in metadata about the package, and we're passing in some stuff about like, here's where my code is, and here's what I need to be able to run my code. And they're giving you setup.config, setup.py, and pyproject.toml. Now the new bit is pyproject.toml. This did not used to be an option to put all this stuff in there, but as of apparently the 25th of March, you can potentially put everything in pyproject.toml. I tried that, it didn't work, so I've come back to this method for now, but that's my expectation, is you may be able to do that within the next 6 months. Okay, so let's change this stuff. DXW. You start with, I mean, I would start with 0, I think, but I suppose you could start with 1. I don't know. Now, this is the line that's going to need to change. If I save this, I'll get some highlighting. This is the line that needs to change. So it's like use this for flat layout. but I'm not going to do that, remember, so I'm going to comment that out. Use this for what's called the source layout. So what did I do? Oh, in fact, you use nothing for the source layout. And actually, this thing, obviously you would change this, DXW. But I see, this is the sort of thing that I don't like. I don't like having two places where I need to change something. Like that, you know, you want to try and avoid that kind of thing, because if you do change the name of your package or whatever, or you use this as a template for the next thing, that's going to trip you up. So what you can do, and again, this is all relatively new, is you can replace this with find : Okay, let me just uncomment that so you can see exactly what I've written. So if you're using the flat layout where you don't have a source folder, use this find and it will automatically scan. Now, how does it get by without naming the package for a source layout? It's automatically scanning. I don't really know why it can't automatically scan the flat layout in the same way. It needs this hint, but the source layout doesn't need this hint. Okay, so I'm going to say for now, this worked for me. Now, this is super minimal, right? We have literally just copied exactly what we were given in this documentation, except we've even deleted this line if you're using the source layout. So with that, I've saved that. There are my files. Let's look at the tree again. It looks like this. Is everyone okay? You're a little behind on the vid. Okay, Matteo. Yeah, no worries. Cool. So let's see what it says in the docs, because I can tell you if we need. Yeah, so that's it. Believe it or not, we're actually done. And oh, I guess I could have said, if you try this PyProject.toml, big letters, experimental. And by the way, this actually did work for me when all I was doing was this. I ran into trouble when I added more metadata. So it wasn't quite yet that I fell off the PyProject.toml horse. So by all means, give that a go, because if that works, you're in the wonderland. Like you know, basically you've got one file that builds your project, and that's the dream. By all means, give it a go. But like for now, I felt like I needed to stick with the config file as well. It's too bad, but like I say, this could be the year where Python packaging becomes amazing. Okay, now we can do Python -m build. Don't worry too much about this. This is a way, what you're doing is you're saying, run this package as a Python, like it knows how to run something, essentially. It's kind of like IPyKernel, and there's some other things out there that you might have run before in the same kind of way. Pip works like this too. You can do Python -m pip, even though pip's a pip installable package, it's got a way of running as a program. So let's try it. It's not going to work because I'm not sure why, but build doesn't come with Python. You need to install it. So it did install some things along with it, like a package called pet517 parsing. Okay, so now it should work. Let's go back to Python -m build, and stuff is happening. Yeah, good question, Michael, about highlighting the config and the toml. I don't know if I go back to my file there, I don't know if I can see what's running to do this. I'm sorry, I can't remember. Maybe, I don't know how old you, well, it self-updates, doesn't it? Okay, well, it's finished this thing over here. And what, you know, if you've done a bit of packaging before, it's quite interesting to read this, because you'll find that it's doing quite a bit in the background. It's actually setting up an environment. It's installing your package in this isolated environment in order to build it sort of cleanly. It's looking for all sorts of files, like it added the license file by itself. It's making this stuff in egginfo, and it's building up your package and finding all the files and so on, copying the README, like it knows about all this stuff. So there's a ton of like automation happening here, super convenient. And in the end, it comes down and says it's building an sdist, or it's built the sdist at this point. So it builds the sdist, that's this egg info business. Sdists are sort of the old way of building Python packages. They essentially contain all the files needed to build and the instructions for building the project. The new thing is this wheel, and the wheel is faster to install because pip can literally just copy it into the person's Python environment. It doesn't have to run anything. So it's much more kind of streamlined, and the wheels are the new thing. Or new, I mean, since about 7 years ago. But the only reason that it still kind of builds and gives you the sdist is sort of for backwards compatibility in case someone's running some super grungy Python environment. So because you can see at the end, we get both a tarball, so tar.gz, that's the sdist, and we get a wheel. So if you Google like Python sdist wheel, you'll get a bunch of explanation of what's going on there. I don't really follow it all that closely. In fact, we're going to upload both of these things to PyPI. So, are we ready to do that already? I think we are, basically. So, in order to do that, oh, no, I'll tell you what we can do first, actually, because right now, if I run Python in my environment, I can't do that, right? It doesn't know anything about that. Oh, I have forgotten something, actually. Just realizing that I didn't add an init file, so I'm a little bit surprised that it built. Do we do it, or should we just not do it and see what happens? Okay, I'll tell you what we can do. We can do this. Both of these files are pip installable, so you could email this to someone and they could pip install it. I'm going to pip install dist dxw. I'm going to pip install the wheel. Oh, I tried to import foo, not dxw. Well, it seems to have worked. Can't remember what I called my dtw. That's probably a poor choice of name. Yeah, so I think what's going on there is it actually is not working. So we need to add the init file. I think in the back of my mind, I felt like something was like it couldn't be that simple. So we're going to make a new file here. Now you'll read a lot of things saying this file can be empty, blah, 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 but actually it usually isn't empty. And I've found that normally what you want to do in here is sort of, this is where you basically tell the package and the import mechanism what you want to be able to see from what you've written. So what I'm going to do is say, whoops, from .dxw, which is my file, import dtw. You know what? I'm going to rename that function because I'm going to get that wrong every single time I type it. And I can decide at this point if I want a user to be able to easily use these other functions or not. Like if I don't import them, they're not going to be sort of exposed in the same way. If I do want just everything, I could do this. Now I know you've probably seen and read people saying don't use import star, but I feel like I see this a lot in init files, and I think it's if you've got a lot of functions in a file, the last thing you want to do is have to just list them all. So I feel like that's reasonable. So I'm going to leave it like that. Now I'm going to save this. Now it has to have this special name. It's __. aka dunder init.py. So dunder init.py. So that's double underscores around the word init. All right. Okay. Sorry about that. Forgetting that was kind of crucial. Now, I think if we go through the build again. Now, while it's doing that this time, I just want to make sure that you have an account on, let's do test.pypi.org first. So go to this URL and make an account. And then there's another one called just PyPI.org. So drop the test and make an account there as well. I would use the same password on each of them. I guess that's not strictly sort of best practice, but it'll help you not go nuts. And once you've got, so just make sure you know the username and password because you're going to need them in a minute. Now, the next thing you can do is actually make a file. Let me just see what it's called. It's called .pypirc, but I can't remember. Now, this may or may not be sketchy, but what you want to do is make a file like this, except scroll down until you can see the PyPI ones. So yeah, okay, so this is a safer way of doing it. So that's the code you want. I'll put it in Slack. But this is using tokens. Now you can make the tokens from your account once you're in there. Actually, can you make them? I've always made them for individual. Okay, API tokens. So you want to come down to here and go add API tokens. So this is once you're logged in, go to manage your account, scroll down to API tokens, add a token, and then call it, I don't think it matters. This is just a label saying here's what this token is for. So you're going to do it for DXW or for your project. And then the scope you can't use yet. Actually, you know what? I think it's fine to use this. Just make it for all projects, and then your .pypirc file kind of makes sense. So choose entire account. Now, obviously, that just be aware that that exists. So at least you're not putting your password in plain text, so it's not that bad. But yeah, it's either that or you're entering your username and password every time. So if you prefer to do that, that's fine too. Okay, hopefully that made sense. If you're just entering your username and password for now, let's do that. This has built. Let's just check that the thing I did before works now. So I'm going to pip install dist dxw. Okay, so now I can do stuff. And there's our results. Okay, so lovely. This is the current state. Oh, yeah, so let's talk about this. You're like, hang on a minute, there's more stuff there. Or at least that's my reaction. There is more stuff there because remember, the build process built this dist folder and put our two assets in it, the sdist tarball and the wheel. And we only really strictly need one of those, but we're going to upload both of them to PyPI because that's what you're supposed to do. And it built this thing called DXW egg info, which contains a bunch of things that we had nothing to do with. And yeah, that it does. If you use the flat layout, this folder will be in your main project level, not in source. Yeah, I mean, basically, you're just going to ignore that folder. You can delete it if you want. It doesn't matter. It'll rebuild next time you build. Just ignore it. It's in .git ignore. Setup tools knows to ignore it. Setup tools ignores this. In fact, there's a whole list of folders which setup tools will ignore and not put in your code in the wheel. So there's lots of things that are sort of automatically being detected in the background, and it's going to ignore this stuff. So, you know, essentially just don't worry about it. I think you can tell tree to ignore stuff. If you like the tree view, you can sort of give tree like some regex to ignore things, but I'm not going to do that. All right. So I declare that we're ready. Now, there's a bunch of ways you could probably upload stuff to PyPI, but by far the easiest one is using Twine. Let me just dig something out here. Because I can't quite remember how to do that with the test PyPI history. Okay, so we won't have Twine yet. So you're going to pip install Twine. Twine's one of these just wonderful packages that just works beautifully and saves you. Having said this, it's going to do something horrible to me, isn't it? But it's just one of these things. It's just so great. It just does exactly what it says on the tin. Now, so it uploads stuff to PyPI. So we're going to go Twine upload -r test PyPI, and then we're going to go dist/star. And if you've got a PyPI RC, okay, if you've got a PyPI RC with a token in it or with your username and password in it, it should just work. Or if not, it'll prompt you, I think, for your username and password. Hopefully that worked for you. I can go over to test PyPI now and look up DXW, and there's my package. Half a minute ago. Not much to see. And actually, we're used to seeing some things down here, like homepage and description here, and those aren't there. And actually, if you noticed, when we did the build, there were some things, there were some warnings. Here, warning, missing required metadata URL. Missing metadata author email or maintainer. I think they should probably just put those in the examples since they're apparently required. Although I guess nothing actually required them in the end. But they didn't, so we're gonna add those. Now we can actually pip install from. I'll just uninstall my local DXW. We can install it now from PyTest. This is one of those things I can never remember how to do. Oh yeah, I know. In fact, you know what? I put it in here because I can never remember how to do it. Here we go. It's this. So the thing is, if there's a couple of ways we can tell pip about another repository, because by default it's going to go to PyPI, and we haven't put our stuff on PyPI yet. But if you just tell it, get my stuff from test PyPI, then it's going to try and download NumPy from there if it doesn't have NumPy already. And you don't want that. So if you use this extra index URL, then it'll only use PyPI for the things that are on PyPI, I guess, or something. So now let's try this. So pip install extra index URL, the test PyPI /simple, and then my package DXW. And did that use a? Oh no, it downloaded it. There we go, downloading. I was going to say, did it use like a local cache or something weird? But if I go into Python, I can now import DXW. Cool. So that we did it. Let's do Twine. Now for Twine to upload to PyPI, you don't need the extra bit. So we can just go dist/star like that. In fact, actually, I think you can miss that off. No, you can't. Okay, fine. Now, be a bit careful with dist/star because as you add versions, you may have different builds in dist, and there might be a lot of things in there, some of which are broken or you didn't care about or whatever, out of date. So just maybe either keep dist clean or tell Twine exactly what you want to upload. All right, so now that should also be on PyPI, which is this one. And there it is. How are people doing? All good, sounds like. Disable SSL certificate for pip. Yeah. If you're on Windows, Michael, did someone help you with that? Because there's a thing you can pip install that I feel like often seems to work. It's called something like Python Win Certify. Python Certify Win32. I don't know what I'm talking about, by the way. I don't use Windows, but seems like when we have trouble with certificates and HTTPS, that sometimes fixes it when we're teaching and whatnot. All right, so that was Twine. We are in good shape, and in fact, I think if I come back here, yeah, we've done. We're in the profit rocket stage. Wicked. Now, what next? Okay, so let's go take a look at some things that we skipped over a little bit. And the first one I want to look at is more metadata. So I'll give you some boilerplate here in a sec. So this is going to go in setup.config and it's going to go underneath here. Now you saw that it said earlier we had some stuff that was missing. So one of them was URL. And for this we should give it the, I'm going to give it the GitHub, but whatever you consider to be the URL. You notice there's no quotes around these things. You can give it author or maintainer, whatever you like. Author email. And now some fun stuff. We have a description, simple dynamic thing warping. Time, depth, whatever. I guess I could put it in space. And then let's do this now, just in case I don't want to forget. We're going to do long description because you're almost always going to want to do this. And this is actually going to be a file, and this is going to be your readme.md, what we have right now. Whoops. Really don't like it when it does that. And you just want to say this, long description content type is Markdown, so that it knows how to process it. And then there's a bunch of classifiers. Now I'm just going to give you these. In fact, why don't I add it and then give you all of it? Now these, as I understand it, just help people, pip, crawlers, I don't know, figure things out. And there is something in there I haven't talked about yet, and that's Python versions. And we're actually going to add something to our options on versions as well, because it may be that you're using some new feature, maybe you're using a walrus operator, or I don't know, some of the new stuff that's in 3.10, or you're assuming that dictionaries are ordered or something like that, and you need to constrain the version of Python that you're supporting. Now, this is just metadata. This does not have any effect. What you really need to do is come down here and say Python requires, and I'm going to say greater than or equal to 3.6 because I think I can support anything like that. Sorry, I just noticed something. This is wrong, actually. I should have spotted that earlier. Apologies. I just copied, remember, I just copied this from the thing. In fact, I need NumPy, right? So sorry about that. I need to change that bit there to the thing that I actually require. So my package currently is essentially broken because if someone tries to install it into an environment that doesn't have NumPy, it's not going to automatically, it's going to automatically install those two things that were in the boilerplate, but it's not going to automatically install NumPy. So that was an error, but it'll be fixed in the new version. I guess, so we could bump the version here. In fact, you will have to, because PyPI won't let you, I'm pretty sure I'm right in saying, won't let you install a version on top of another version. So we're going to have to move that version up there to 0.1 for when we upload it next time. Now, one of the things about packaging and what makes it so tricky is that Python has no convenient way for it to know its own version. A package has no introspection for version number like that. Now, there is a way. It's fiddly, but there is a way to do it automatically from GitHub tags. And I recommend that you do it that way. In fact, why don't I just, before I forget, show you a place of mine that I know, where I know that that's been implemented in a way that works. I won't say correctly. So sorry, just go to Agile's GitHub and you're looking for a package called Snowflake. And Snowflake, I think I'm right in saying. Yeah, Snowflake uses, so you see what I'm talking about. It's kind of horrible, but there's a get distribution from package resources and blah, blah, blah. So you need the bit that goes in init.py in your package, and you need a bit that goes in setup.config, which is this here. So that version number gets replaced with this special thing. So in other words, it's looking in the package for Dunder version, which is all this init.py is doing, is setting up Dunder version, right? It's all to set that up. And of course, you've probably used this in other people's packages. You want people to be able to go import dxw, dxw.dunder version, and get the version number. This is how you do that. Or this is one way in which you can do that. But it also, does it need anything in here? Yeah, you also need these lines in the TOML. And you need this. I warned you, right? It's not nice. But this gets the tags from Git. And just to make it all really dandy, at least when I built Snowflake back in November or December, you also needed setup.py with just this one thing in the setup function. Super annoying. Now, I think that bit might have gone now. I think that the new version of setup tools lets it at least know the name of the package. You'd think it could do that, right? Because it's right there in setup.config. So, I mean, it's kind of weird that you can't just use that. But I think that might have changed. So, other than that little footnote, there's how you get the version number being done automatically. But honestly, the first little while you're maintaining your package, to be honest, I would just remember to bump the version up. Now, bumping the version reminds me of some other kind of metadata that we want, right? Well, let's do them in order. Sorry, VS Code. Okay, so I think that's all we need in there for now. We're also going to want new file. Well, I'll tell you what, no, before we do that, let's do open the README. So we haven't done anything with that yet. Right now, it has basically nothing in it. So time depth space or whatever warping. And in here, you know, it's the usual stuff, right? You're going to put things like installation is often what people want to know. You can install with pip. Documentation. Coming soon. Lol. Contributing. Please see. I'm just going to write it like this for now. Oh, we can link. You should be able to link to a file. Misspelled. Not totally sure if that path is going to work later. Now, obviously, I'm just hurriedly filling things in here. Go check out other people's projects. I mean, I mentioned it earlier, but Leo and Santi's work in Fatiando is amazing. So you can see how they've done all of their stuff. Of course, it's all open source. That's where I get my inspiration from, is those projects, because they're so nicely done. But there's a very simple kind of README for now. Now, I just mentioned contributing. We better make that. Thank you for considering contributing. Here are some things you can do. Make issues when you find them. Okay, maybe I'll do this. Okay, that'll do. So there's that. Now we'll call that contributing. Now GitHub and various other people sort of try to measure the openness and awesomeness of projects, and these are the sorts of files that they look for. Now there was another one. Well, you can go and look at one of my projects or Leo and Santi's projects to see what other things people include. But they're things like lists of authors. What else? How to cite a project, especially if you've got a paper about it or something like that, or you want people to cite it in a certain way. Oh, what I was going to do was the changelog. So this is an important one. So we'll just say first release, broken, do not use. I mean, if there wasn't so I guess one thing I would say is, well, no, it's probably a good idea to be somewhat stressed about what you put on PyPI. Like, check things, run your tests, try not to break things, put your requirements in and so on. But don't let the stress become so much that you don't publish your package, right? Someone can always go back to your GitHub and try and figure it out. They can put an issue in and say, hey, by the way, this didn't work. Are you missing a requirement? Did you accidentally leave boilerplate in from the help page? Like, it's not so important that it should get in the way of getting your stuff out there, right? And if you don't get it out there, you might never discover some of the errors. So it is like, I mean, you know, from my own experience, sitting there sweating about, oh, have I run everything? Does this actually work? Am I just about to do something stupid? And you know, yeah, 20% of the time I am, and I push a new version and then go and tweet about it, and then 5 minutes later someone goes, actually that's completely garbage, and 5 minutes later it's fixed and it's like it never happened, so it's all good. All right, so there's my changelog. I think we've got all our metadata, we've got our README, I've just fixed something important. Let's, there's all my new files. And now there's a URL, so that will be on the PyPI. So things are getting a little bit more usable. Python -m build. Now this should add new files, right? Because they'll be called 001. Now, what's all this 0.0. What's name? This is probably poorly executed semantic versioning. Semantic versioning is quite a rigorous, formalized way to version packages. And I recommend reading at least a little bit about it before you start putting versions on things. You know, you need to understand a bit, I would say, about what does it mean when you break the API? Are you allowed to break the API with this version? What's a bug fix version? That kind of thing. Most of my packages are in 0 point something. So in other words, they haven't even reached they haven't even reached version 1 yet. And I don't know how closely this matches the formal description, but in my mind, that means that when I come across a 0 point something release, I can break the API. Things can change. Now, you try to deprecate and do it nicely, but fundamentally, you know, you're in alpha, essentially. Or maybe it's beta, I'm not sure. Do go and read that page. Don't listen to me. Okay, we've got 2 new versions. I'm going to go twine, upload, dist, /. Now, I have to be a bit more careful now because there are 4 files in here. Oh, sorry, star. And we can go check it out on here. Okay, so here is now my bumped version. There's my project description. Remember, that's coming from the README now because I did that include README business. And I've got my project link homepage thing here, which goes back to GitHub. Very nice. Let's talk a little bit about documentation and testing. I'm not going to have tons of time here, but we'll try and do something just to point you in the right direction because and any amount of attention paid to this stuff will be appreciated by both anyone who tries to use your project and by you. Okay, so let's write some quick docs here. I'm going to have to do it really quickly because we're coming up on our time too. But I mean, I'm not going to lecture you on how to write good docs, and because I'm not going to write good docs right here. I loosely follow. There are 2 main formats for doc strings. There's Google style and there's NumPy style. The NumPy style uses sort of, I'm sure you've seen them online, but uses RST, basically, this restructured text format, which I don't like. The Google style is a bit plainer. It tends to be the one that I use. I recommend choosing something and sticking to it, or using some sort of formatting tool. People like Black. A lot of people seem to like a tool called Black. I've put some links to that in the rest of that presentation. You can check it out if you want. And I'm comparing this to NumPy style. I guess the other sort of, you could see it as a form of documentation that a lot of people use these days are type hints. Obviously up to you if you go and implement that kind of thing. So I'm going to go args. See, this is where I wish I, in fact, oh, I've got to sign back into Copilot. Copilot is awesome for writing docs because it just basically fills them in for you. Yeah, Copilot has saved me so much time, I would say, since I started using it all the time, basically about 6 months ago. And I wouldn't say I can't live without it, obviously. Maybe if I'm writing JavaScript, that's true. But that's something like a Google style thing. Now, it's always nice to have examples. And I'll show you a trick. If you write your examples like this with the little carrots as if you're a REPL, you can do something nifty. So let's say S1 equals I'm just going to use lists. I think that's going to be okay. Use something like the one I did earlier. Actually, I can just make it even shorter, can't I? And then I'm going to call this function get cost on S1 and S2. And then, since I can do this in my head, let's assign that to something. And let's say that the cost.shape, I'm going to ask for cost.shape, and that's going to be, well, actually, it doesn't matter if I get it wrong because we'll all learn something. So let's just say it's going to be 8.5. I can't remember which way around it's going to go. Okay. There is an example in my docs of how you might run something like this. Now, the cool thing is that when you've got that kind of thing, you can use something called doctest. Now, I could go into that file. Doctest comes with Python. I could go in there and, gosh, can I actually remember how to run? On that file, maybe? Okay, I was right. Let me show you what happens. Well, I can run this with verbose. So what's happening is, so this means Python, run the module called doctest as a program, run it in verbose mode and run it on this file. And it goes and it looks for these lines that start with the greater than symbols, and it runs them. And then it checks that the thing that it got, you see, it says expecting 8.5, and it says okay. In other words, it passed. If I'd written 5.8, which is the thing I couldn't remember, and then run this, I would have heard about it. Oh, sorry, even if I didn't run it in verbose. Okay, so there I am running it just like normal, and it's like, oh, I expected 5.8, but I got 8.5. So that's cool, but actually we might want to write other tests, more complicated tests that we don't want to put examples in for. So let's do that. I think I've just got time. So I'm going to CD back to where we were, and let's make the tests. So someone was asking earlier, Michael was asking where to put this. And then I'm going to make something in tests called test.dxw.py. So it's going to be a Python file. And in here, I'm going to write a different kind of test. Tell you what, let's do, so everything has to be a function. It doesn't need anything. And I'm going to, let's say I'm going to assert, well, let's do this. Path, comma, sorry, can't remember which way around I passed stuff back in. So it's path, comma, cost. Path, comma, cost equals, actually, do I? Sorry, just checking something. Can't remember if I need, yeah, of course. Let's do this. Sorry, import, I think I can, no, let's do from DXW, import my function DXW. Okay, we're going to need that. And then we can do DXW on a signal and an empty signal. And then let's try and assert something. Now, you're probably thinking, well, we haven't handled this, but yeah, that's right. Cost.shape. Well, actually, I discovered something totally weird yesterday, which is that you can have zero, a NumPy array can have a dimension of 0 size. Let's try this instead. Let's go path is like empty or something. Sorry, I'm kind of making this up as I go along. So in case you can't tell. So now I'd like to run this test. Now there's an awesome suite for testing called PyTest. It is not built in, so we're going to need to pip install it. And if I run PyTest now just right off the bat, it goes out and it tries to find your tests, and it's basically just looking for things called test something in folders called test something. And you can see that it found my test and it got an exception. So I need to figure that out. Basically, this sort of broke. So what I might do instead is, for example, say, okay, well, if S1, I better use len because with it, you know, I haven't guaranteed that these are NumPy arrays, and I'm not going to implement that right now. So if len is 0 or len of S2 is 0, then raise a value error and say something like, you know, signals cannot have 0 length. Okay, so because my stuff breaks basically when it's empty. Now that's probably a bit more user friendly, but it doesn't fix this because now it just gets. I was expecting it to get my exception. I'm not sure why it didn't. Now, okay, if this is using my installed DXW, so normally I like to run PyTest on my code base, not on my installed file, and it was using 0. So I feel like this is a thing with my source directory, and that might be the thing that breaks my favorability of that method. So just exactly like I predicted, I think I said 45 minutes and it was closer to 55. I'm going to backtrack on that decision. I'm going to uncomment that. Let's see if I regret how badly I regret this. I'm going to move source /DXW to here. I'm going to rm minus rf source. Let's just check that I did that properly first. Yeah. This is great. I'm just gonna rm minus rf this. I don't need to do that. It was the egg I was worried about. My prediction is that that PyTest will work now. Did I change my config? It did. DXW. I don't totally. Well, no, I've got a init. Try one more time. Okay, if anyone can see what I'm doing wrong, maybe you've already told me. Running PyTest with DocTest modules. Yeah, that's what I was aiming for, Santi, but now I don't know why my PyTest doesn't even discover this test, because this test seems to be... Let's just get rid of that PyCache as well. Yeah, this is how I normally do it. So I'm probably just missing something incredibly straightforward. But I can't see what it is. Oh, that's gone, of course. but I can't see what it is. So I'm not going to worry too much about that because I've only got a few minutes. But yeah, what I was heading for was, as Santi's just pointed out in the chat, if you add this doctest modules to PyTest, PyTest will run both the tests that it discovers, if you can get it to discover them. Yeah, I mean, I guess, yeah, fair enough. I could install it. But normally I'm running against my code base, not. But this will solve the problem, I hope. Oh, I need to rebuild. And then install that. So now I'm running against, like, I have to build and install, which is not very convenient for while you're writing code and trying to test. There are other ways of solving that problem too, but that's just my normal workflow. So I'm not totally sure what I've broken, but let's, let me at least show you this utils business. So all code does, Matteo, is it opens in VS Code. So just go and open it through your through a thing. Now, what? It's so weird that it's not even seeing that other error, because it should be. It should be raising this error. Whoops. Haven't done anything weird there, have I, with my logic? I don't think so. So, sorry, I got rather sidetracked by that. That was doing things a bit out of order and so on. But with luck, this one will do it for me. And I can just show you that one thing that Santi was trying to explain. So. Okay. All right, okay, excellent. It threw my error. Now, I want to show you this. We can handle that. If we import PyTest in here, it has a mechanism, if you like, which I guess I will put here and say with pytest.raises, specifically the value error, that needs to go inside this context. So we don't need to assert anything as we're using that context. If I run this now, that passes. And like Santi was saying, I can also do pytest doctest modules. And now it also runs my other test that was in the docs, right? So this one, which I changed so that it was wrong. Let's change it back. Now I've got two tests that are being discovered, one by doctest, one by PyTest itself, and they're both running and they're both passing. Now we can also do, there's two more things I'm going to squeeze in. One of them is this business here with this option, because actually there's a better place to put this doctest modules option. So it should really go in our configuration, right? Because we want ideally to describe the entire process with just our configuration. So I'm going to put it in setup.config, and it goes in its own section. It goes like this: tool, PyTest, and I can say add opts and put that doctest modules. And now, if I save that, so all I have to do is save it. I don't have to rebuild anything, or, well, actually, with the way my PyTest is working, I guess I probably do. No, I didn't. So I just ran PyTest on its own, and it's now picking it up from setup.config. So that's cool, but it does mean, notice that we've started using more tools. Like I had to install build. I installed PyTest. I may use other tools. So I recommend doing this, which is adding some extras for pip. So this is extras requires. And what I usually do is set up, have like a test setup, which says, hey, if you're going to be doing testing, tell pip that. And it will also install PyTest for you as a dependency. And the other thing I usually do is have a dev build. And I put build in there and PyTest. And that's sort of for other developers who might, you know, want to know what they need to actually build your project. I guess you could put Twine in there as well if you wanted to. And now a person, once I push this, would be able to do this, pip install dxw square brackets dev, and they'll get all the things, all the dependencies that they need to run developer type stuff. And this also turns out to be a really convenient way to build like continuous integration, because later on you're going to want to install your package locally so that your continuous integration tools can run. And this is a nice way of saying, oh, if I'm building all my docs, then I'm going to need Sphinx and blah, blah, blah. And always lots of ways to crack an egg. But I think the concept is you want to put as much stuff in your build files, soon to be hopefully file, just pyproject.toml, and everything's in there. So there aren't these little, and the nice thing about having stuff like this adopts is now, because some people put that in like a .pytest init file. There's another tool that I use a lot called coverage, which I can show you quickly. Actually, I'll do pytest cov. If we come over here and go pip install pytest cov, that's installed now. And now if I do, I've got the option right there. So now what it's doing is saying, okay, in your files, you're testing, you've got 31 statements or lines. You've tested half of them basically. So your coverage of your tests is only 48%. And if I want to know which 48%, I can do a little HTML report with that coverage HTML. And then let's open that file that it's just made, which is in HTML cov index. And we get a really cute little report here, just as a static file locally, where I can click on here and it actually shows me my code. And then in red is the stuff that I haven't tested. Now, actually, I did test this with the doc test, but I guess I hadn't noticed before that coverage can't tell that. So this is in red because my PyTest doesn't, all it's doing is testing that exception, right? So if I make another one that's basically like, well, I won't do it because we're out of time. But if I make another test which does run my actual code and stuff happens and I make a cost matrix and a path, then I'm going to have, I'm guessing, 100% test coverage because there are no other conditionals in here. Wow. Okay. You know, I'm pretty used to the wheels falling off at some point. I know that's not totally comfortable for everybody. I apologize. I'm actually still a little bit unsure what it was that I broke, because normally PyTest works for me like that. But like I say, probably something super simple that I missed. I will tidy this repo up a little bit and I'll push, well, yeah, I haven't pushed for a while, so I'll push it so you can take a look at it in GitHub if you want to. Back in my presentation-y thing here, I've got a few more slides on like the stuff that I showed you that I linked to, the blog post that I showed you, some of the things I dropped into Slack. And then a whole list of things that you might want to look at next, right? Now, you can go a super long way with beautiful doc strings in your functions and PyTest. Those two things will take you miles and miles and miles. You do not need to worry about, I think I'm right in saying, basically anything on here until you get more comfortable with the fundamental tools. But do poke around once you do get comfortable with it. Please, please, please publish a package. Like, we need more Python stuff out there, especially for subsurface. Like, even if it's just doing one thing or making a cool plot or one bit of analysis or one equation, it's fine. Get it out there, share it on on Slack, tell everyone about it. You'll get tons of great feedback, I promise. I mean, I know that I'm speaking from a fairly privileged position, but so this isn't everybody's experience, but I can say universally, no matter how rubbish I suspect my package is, somebody somewhere appreciates it, or at least says, nice one. And it's and that's lovely. We have a great community. So please jump in, get involved, get it out there. Good luck. Come back for help if you need it, and let us know how you get on. Don't forget to subscribe to our channel in YouTube. Hit the like button if you liked most of what I did and didn't hate the bit where the wheels fell off too badly. Otherwise, I'll see you soon, I hope. Take care, everyone. And I'll awkwardly press my stop broadcasting button.